All right, guys. So we are getting ready for our CUA. We finished up the unit, and I just wanted to kind of break things down for you. This will be a two-part review. So today we'll talk about one of the concepts. Tomorrow we'll cover the other. Uh, but to start out with, before I actually start writing any notes, I want to make sure that we all know where to find the star chart in our Schoology uh, sections. So if we're looking at our home page, and it shouldn't matter whether you're in first, second, third, or fourth, you should see it right here on your screen. Okay. Make sure we have that open because when you go to your CUA and you click on that link, it's going to open in a new tab. So basically, you'll be able to reference this and that at the same time. So you can download it if you want to click right there and just download it to your device, or actually print it if you have access to a printer at home. So you're not having to tab in and out of your CUA. But in any event, you need to have this. Okay. This is extremely important for our CUA. These are all the formulas that we're going to need, especially right here in these two sections, right? Surface area and volume. And as long as you have those, you've got just about everything you need to figure out whatever they're asking. Okay. So very important that we have that open, and then going forward, that's what we'll be referencing as we talk about the different concepts. Okay. Um, so let's just go into our unit review. Okay. So unit 8 review. It'll be day 1. And the first note I'm going to put on here, as well as tomorrow, um, use the star chart. Okay. I can't stress this enough, guys. Without this chart, you're somewhat guessing at some of the formulas, and there's really no need. They're providing them to you so that you don't have to try and memorize those formulas. All right. So limit your memorization to what information we cover today. All right. So today we're going to break this up in 2 days. So today's topic is just going to be surface area. Okay. So surface area for us meant two different things, right? There are two different ways to look at surface area. First, you had lateral is just the sides of the object. Okay, so just the sides of the object. And we liken that to paint the walls. Okay, so if you're thinking about a room, which would be a rectangular prism, right? Um, we have paint the walls, right? We're just going to be painting the sides of that box. The other would be total. Okay, and so total surface area implies just that, all sides. So an easy way to remember that, right, is to say faces and bases. Okay, because the bases are how we find the different formulas, right? The area of the bases. So faces are the walls, right? So walls, floor, and ceiling, right? And we liken that to wrapping a present. Okay, we want to make sure that whoever we're giving that present to cannot see any side of that shape, whatever it is. Okay. And so those are the two things we're watching out for, right? In the word problem or the scenario that they give us. Are they talking about just the sides of the object, or are they talking about, right, everything all together? Okay. And so when we want to look at these different things, obviously we want to look at the formula as well. If you go to your star chart, again, looking at your star chart, if I'm sharing the screen with you again, you're going to notice in surface area, there's really only two different shapes. Okay, so you have cylinders and you have prisms. Now the prisms, right, can be a lot of different things depending on what their bases are. A cylinder is has a circular basis, so you'll see pi is included in that formula. Okay, so we're going to go through one of each just to make sure that we have it, and talk about the parts of the formula for each. All right. So first up, right, we'll do a triangular prism, for example, 1. Okay. And, we'll draw that out real quick. So we'll just draw ourselves a triangle. Okay. And then with that triangle, we're going to match, cup it up and over just like that. And now we can connect our sides. Okay. So there's our triangular prism. We can put our dotted line in here so that we have, right, the dimensions, and we can see all the sides. So how many sides total do we have? Well, there are 5, right? So we have 2 triangles, and then we have 1, 2, 3 rectangles, right? We have these 2 that are slanted up, and then we have the bottom of the shape here that would be lying flat on the floor. Okay. Now, important to remember, if it's a triangular prism, that is telling you, right, the name of the base. That means these triangles are our bases for this object. Okay. So let's give it some dimensions. It's going to need a height for the triangle. Okay. So we'll call that 8, maybe 10, and we'll go 15 here. We'll also include some other measurements. Maybe that's 12. Okay. And just to see, right, we'll go with meters on our units. So very large object, right? Because a meter is like a, the meter is, let's see, and this one would be 12. Okay. It's like a yard. Okay. So let's look at our formulas. Okay. Now there's another way to do this. If we wanted to, right, we could just find each shape individually, and then we could add those together as needed, right? So as long as you remember what your bases are, right? So we have 3 rectangles, 1, 2, 3. Those are going to be our sides or our lateral area. And then to that, we would add the 2 triangles, right, which are identical. So finding the area of each one. So we'd have 5 shapes to find if we were to do it the long way, right, by drawing out each shape. And you're welcome to do that. And if you want to review that, that's going to be in one of our videos from a previous week. I believe that was the last week in January. So be looking for that date. And you can review kind of how that strategy works. But I want to focus on the formulas. Okay. So what they give us for lateral is S equals capital PH. Okay. And that's it, right? That's the formula they tell us for lateral surface area of a prism. And so let's define, right, those 2 things. The capital P, if we'll remember, is the perimeter of the base. Okay. And then more importantly for us is H. Okay. Because H has always meant height for us, that is true. It is the height. But it's also what we need to know is the distance between bases. Okay. And that's important on these different objects, is that we recognize the height might not always be up and down. Okay. So as I look at this formula, so I'm going to say LA equals capital PH, right? I want to fill in what I can. So S equals the perimeter of the base. Now, this is important, right? That I know what a base is, because in this prism, right, a lot of us are going to want to say, oh, the perimeter is the distance around this rectangle at the bottom. And that's not true, right? This is not the base. This is actually one of the sides. In a triangular prism, it has triangular bases. So they're essentially talking about this triangle here as the base. So we need to find the perimeter of that. So we've got 12, we've got 10. We don't have this side here, but when we look at a prism, these are rectangular sides. We know the opposite end of this rectangle is the same measurement. So we've got 12 and 12. So 12, 12, and 10. That's going to be 24, 34 is the perimeter of the base. Okay. So 12, 12, and 10. And then when we look at the height, right? Very misleading right here, right? We've got a height. It's the height of the triangle. But again, by definition, the height is the distance between the bases. So really the height of this prism would be the distance between the two triangles. Okay, so those are our bases. And so I need to look at the distance between them, which is 15. Okay, so very easy mistake to make there is to grab the wrong height. Okay, so really I've just got 34 times 15. So that's 340 and then 150, 170. So 340, 170, that would be 510. And this is area. So meters squared. Okay, and that's how we would do that one. Now, the other we need to worry about is the total. Okay, so little note for myself on total. Okay, it is S equals capital PH plus 2 capital B. Okay, so we already know what this one is. We already know what this one is. We need to know what capital B means. And a lot of you are ahead of me already. You know where I'm going with this. Capital B means the area of the base. Okay, and that's important because, right, we need to be able to identify the bases in our shape. Okay, because all I'm going to really do is add 2 of those areas to what I already have. Okay, so for our SA, right, which is our total, again, this is our formula, 2B. And now we already know pH, right, because we just found it. It's 510. So there it is, right, 510. Now, area of the base. Okay, you got to go back to your bases, again, triangles for this one, and we can look at those separately, right? So this triangle on our notes looks like this. Okay, and it's a 12, 12, 10, and then we've got this measurement here, which is an 8. Okay, so looking at this triangle, right, we're only finding the area of a triangle. So we have base times height, right? 1/2 base times height. That's going to end up being 1/2. And then again, anytime we're looking for a base and height, we're looking for what 2 lines meet at that right angle. Right. So we've got 8 and 10. Right. So 1/2 of 8 times 10, 1/2 of 8 times 10. Well, that 1/2 of 8 is 4. 4 times 10 is 40. Okay, so there's our area. So we have 2 times 40, right? So we're basically going to add 80 to 510 to get a total surface area of 590 square meters. Okay. That's how we would do a prism, right? That's how we work our way through that prism formula. Again, paying attention to what all of these letters mean for us. We need to find those 3 letters capital P and capital B, not given to us. Okay. Not given to us. We got to go find those, right? We actually got to add all the sides of the bases to get our perimeter. We've actually got to do whatever the shape of the base is, right? Finding the area of that shape and then putting that in as the capital B. The numbers aren't present. Okay. Numbers aren't present. So that's our prism. Let's look at the other side of surface area and let's talk about cylinders. Okay. So example 2 is going to be cylinders. Okay, what is important about cylinders? So let's just draw our cylinder. And let's see, it's going to be an oval. That's the top. Okay, and we'll go down a couple lines, just straight down from the sides, and then we'll put a rounded bottom on there. Okay, so let's go here. We'll just say that's a 9 centimeters, right? And then we'll go with 7 centimeters. Okay. So, all right, finding the surface area of a cylinder. We've got surface area formula for the lateral. They give us S equals 2 pi RH. Okay. Now, a couple things to note here. Again, 1 pi is about 3.14. Okay, most of us know that already, right? If we're looking at our answer choices and they don't have a pi in there, something like 17 pi or 18 pi as an answer choice, then that means they probably multiplied with 3.14 in the problem. Okay. 2. Okay. And this one, extremely important for us. Okay. Is R is radius. Okay. R is radius. Halfway across circle. That is the only measurement we use. We do not use the other one, right? Most of us know the other one as diameter, right? And that's what I gave you here is the diameter. We never want to use that. That's definitely going to be one of the answer choices for us. But R, right? That is almost the key to success in these problems, okay? For any circular problem, right, you need radius. Now, H is the same as it was before. H is still the height of the cylinder or the distance between the bases. So again, our bases are circles now. So there's one here and then there would be one down here, right, as the bottom of the shape, okay, if it was there. So we have those two circles and we have the distance between them as 7. So we still know what our height is here, right? That's definitely our height, but R, right? And what I'm going to ask you to do is anytime you see a cylinders problem, because it doesn't matter if it's volume or surface area, we're not going to use that diameter. If you see a diameter on your CUA or anything in the future with a circle, if you see a diameter, immediately get rid of it, okay? Immediately get rid of it and put in your radius. Okay, that way you don't accidentally use that number. It's very important. All right, so we're going to go LA and we're going to go ahead and say S equals 2 pi RH. And so S equals 2 times 3.14 times the radius, which is 4.5 times H, which was 7. Sorry. So all we got to do is multiply all that together and we'll have an answer for what is our lateral surface area on this shape. So let's go with 3.14 times 9 times 7. And I get 197.82. Okay, so S equals 197.82. And we said centimeters, so centimeters squared, okay, because it is an area measurement. All right. So the next one then is going to be our total. Okay, so total. And for total, the formula they give us is 2 pi RH plus 2 pi R squared. Okay, which is just the same as before, right? We've got the lateral plus the two bases, right? Base is a circle, so pi RH or pi R squared would represent area of a circle. So we have two of those. All right. So the easier part of this is I don't actually have to go find it on the side. I can just plug in what I've already know. So 197.82 plus 2 times 3.14 times 4.5 squared. Okay. And all you have to do is type that exactly how it is in the calculator. Okay. Just using the formula, right? Just type it in the calculator. Should have our calculator open just like our star chart so that we can use it during the test. We're all given calculators as 8th graders, so we should be utilizing them. So 2 times 3.14 times 4.5 squared. Okay. And just so that you can kind of see, I did exactly that, right? I just typed it into the calculator exactly how I have it written, right? Exactly there. And there's my answer, right? 324.99. There's no need to do any of this by hand or in your mind or anything like that. Okay. So S equals 324.99. 324.99. And that's still square centimeters because we're still just talking about area. Okay. So big takeaways from this, right? Know what each letter in formulas really means. Okay, so capital P, capital B, the lowercase h, and the R. Okay, what do those letters really mean? And for R, most of us know. H, we want to say height, but we really want to emphasize that that is the distance between the bases, not just the height of the object. And also the perimeter is the capital P, the perimeter of the base, and capital B is the area of the base. Okay, so those are the two, right? And then I guess I would say radius, radius, radius. Okay, those are the two big takeaways for us. No diameters allowed, right? This is an exclusive club. We do not allow diameters. Okay. Get rid of them immediately. Okay. Get rid of them immediately. Aside from that, guys, I think that pretty well covers surface area for us. So both lateral and total surface area. And again, read each problem carefully and identify which one, right? So we can add that in there to identify lateral or total. Okay, very important because a lot of times both those answers are there, but only one of them is correct because it's identified the problem as being a lateral problem or a total problem. Okay, so look for those clues inside the problems. All right. Again, as always, any questions, comments, concerns, just let me know. And we'll try to get those addressed as soon as possible. Be looking for the second half of this review coming your way in our next video. Thanks, guys.